Welcome into the second morning session. So even if you missed the first one, you're here now, which I really appreciate, of the Thursday at VS Live. I'm Drew Squires-Cabala, and we're going to talk about SQL development. I guess we're going to talk about SQL development, but we're really going to be talking about development that involves SQL databases, whether it's SQL Server or Azure SQL Database. It's kind of the whole family of tools that we can apply these principles to, as well as apply what we take away from this session. So if you pick up, I can use this tool, but you're like, oh, I have SQL Server 2016. There's a very good chance that most or all of what we talk about today is going to apply to that scenario, or you're using Azure SQL Database, same thing. So that's the good news. You may notice that a lot of times people just call me Drew. They don't go with the last name. It is Squires-Cabala. That's the phonetic spelling in case you ever want to seem cool and be able to say it. I do work here at Microsoft as a program manager. I work in the SQL tools and experiences space, which is a nice way of saying if you deal with SQL, you have to use some kind of surface, whether it's SSMS or the drivers when you're attaching your application to it, or a CLI. We work on all of those, and it's a lot of fun to try to empower you to build great things on top of SQL. I used to be a developer. I also kind of sat in that seat where you're kind of asked to do those DBA type tasks. I was not one of those really amazing DBAs that you see talk about all the fancy things they do as DBAs, and I won't even pretend. So let's be clear on that. We have the next 72 minutes to talk about development processes, both on your kind of local environment as well as shipping that out. But if you have questions beyond today, you get back to your day job next week and you're like, oh, what about this? Please feel free to reach out to me. I really am very serious about this. Should be about empowering you in how you build and ship things that use SQL. Cool. Feel free to ask me for that contact information later as well. So I can't just dive right into the tools as much as I would love to do that. That's so much fun. But I do want to set a little bit of context around the buzzwords here, DevOps, developer loops, all those fun things. And then we're going to start looking at what do you use when you're working on your laptop. You might have noticed that in the keynote yesterday, some of those demos were pre-recorded. They do that to help make sure that we stay on time. Today, I do not have that luxury. I get to bang away on my keyboard up here, and we'll try through some things together. It'll be a lot of fun. And we'll see exactly like where are the things that you might get stuck on, where are the things that like you're going to be able to step through quickly and really try these things out on your own. I do have some ideas and suggestions around especially the pipelines that you might need to be able to set up for deployment and integration of changes. That's where everyone's environments get sticky and different. And so I don't send you home with like this script that you have to take to your deployment team, your DBA or whatever, and say, this is what we have to use. I'm going to try to empower you with some ideas to say, this is something that we could improve our environment with. And then last but not least, we will take a really brief dive down into the nitty-gritty of a .NET library that basically is like this magic wand for your database deployments. So we'll talk about DAC effects a little bit. So you are a developer in the year 2020, so you have heard of DevOps. You've heard about it kind of changing, hypothetically, application development. Now, realistically speaking, you are trying to ship more often. You are trying to introduce changes in smaller sets. You're trying to have test environments that mirror your development environments. All of these nice things where when you're developing, you have source control, you're collaborating more. Hopefully, you've got some way to work between your database in the development area as well as your application code. Now, it's a nice thing to have, but I'm not going to say you have to have all of that to just start with some of these development ideas for SQL. The other thing in terms of delivery, when you go to ship your SQL code, if you have an application change, you probably have a decent idea of what it takes in your organization to make that change, get it accepted, get that code merged, have that deployed to maybe a UAT, user acceptance testing environment, and then over to production. But those database changes can be a little sticky, depending on whether or not you're using an ORM that goes right with that application code, or you have other quality gates on your SQL code. The delivery of SQL code doesn't always fit as nicely into DevOps as you would like. That's where I really want to get you to a point by 10:45 today, where you're able to walk out of this room or stay here if you're here for the next session and just say, you know what? I am optimistic about being able to ship SQL schema changes. In your organization, there may be an expectation, whether it's in your development team or just from the higher up people, that everyone's collaborating and things are going quickly and every sprint ends with a nice little recap and then you move on to the next one. Whether or not it is the case, it's an expectation of our development culture that we're able to review each other's changes, whether we're able to incorporate branches all at the same time, so you and the person that sits 3 desks down from you can both be working on features that have some commingling of code. The accountability of different people, especially in the database world, there's a question around, as a developer, if I'm building something that needs to change the database schema, what accountability do I have for the deployment and the performance of those changes to the database versus maybe my database administration team, or is there a separate database-focused developer? But at the end of the day, I mean, you and the rest of your team and adjacent teams have the same goal: to ship a working, performant application that makes your company money or saves your company money. So that's kind of something to keep in mind together. All right, wrapping up the DevOps discussion around release cycles. It's not fun, usually, to work on a feature that does not ship for 6 months. Or a year. I mean, there is some satisfaction in knowing, like, I have ground myself in working through something and it was really hard. But it's not cool to, like, tell your boss every week for 6 months, I'm working on it. You want to be able to ship things. And so getting those release cycles down, especially when the speed bump or barrier is I need to make a database schema change, is not cool. So we need DevOps for SQL. At the end of the day, whether we want it or not, we need it. Okay. In the keynote yesterday may have been the first time you have heard the concept of inner and outer developer loops. It's another layer on top of DevOps in terms of a concept. Breaking it down kind of into the most applicable form of it, when we talk about an inner loop of development, we're talking about what you're doing at your workstation on your dev environment where you are making code changes. You're likely starting the local dev environment to test those changes. So if you're going all the way out to the front end, you might be testing things in a browser. If you are building back-end components, you might be writing unit tests against those just to make sure and validate it's performing as you expect. And in this case, even in small team environments, it's very possible that there are multiple contributors to a same larger code base at the same time, especially if you're trying to iterate through code faster. Then the outer loop gets really hairy, because this is when you're trying to integrate people's changes together. This is where you're taking your code from your workstation and your feature branch and trying to merge that into a main branch. This is where if you have code validation, application code or database code, that might happen there. And then the deployment processes themselves. What does it take to ship your code halfway around the world, to the server in the closet over there, wherever? That's that outer loop. At the end of the day, there was a lot of reliance in both of those loops on source control. If I had a nickel for every time I saw a Reddit post or the Google search spike or the Bing team coming to me and giving me search insights on SQL source control, how do I source control my database, I would have a lot of nickels. Source control was really foundational to both of those inner and outer loops. Locally, that's how you keep track of your code changes. That's how your team can collaborate together. In that outer loop, that's how you get the changes integrated together. If you've been to some of the other talks this week, or you're already really familiar with GitHub Actions and Azure DevOps, you know that you can do a lot of great things in terms of security management and mitigation, dependency management, code quality checks, because of source control. So we need our database schema to also be in source control, or at least our database changes, if we want to have control over how our database moves through our inner and outer developer loops. All right. I've done a lot of talking, and so I'm going to ask folks a little bit of a question. I promise I will not remember exactly what you said and like hunt you down later and ask you about it. I know that's not fun for folks, but I do want to know how many folks in here do development that involves working with an ORM, Object Relation Wrapper, Entity Framework. Cool, awesome. So we're like half and half in here right now. I am not going to say one or the other is the right way to go, because it is a 50-50 thing. It is something that depends on your environment, the stack that you're working in. There are those two development approaches. That's why I asked the question. And so with ORMs like Entity Framework, you end up with migration-based approaches, whether it's built into the ORM or using like a third-party tool like Flyway and DBUp. You may even be in an environment where the development process is someone is painstakingly handcrafting their scripts to make the changes, hopefully putting those in source control. That's one way to go about it. The other way to approach database development involves a state-based approach. And if you're familiar with this, this is going to be working with SQL projects or some kind of project-based solution where you're saying, I want to work on a database that looks like this, and then the tooling handles what happens after that. At the core of this, both of these lines of thought have to integrate with the automation that follows. So whatever you're doing for the inner loop, whether it's migration-based or state-based, once you go to that outer loop, if it just stops and doesn't tie in, then you need to question how things are happening. So I want to start demoing some things, so I have to kind of set the premise. This is an example app that we built for Build this year. And we wanted to show off a bunch of Azure SQL database features, which is why there's all those arrows flying in at the database. The first one is a chat bot that was built for Teams, and it writes chat into the Azure SQL database. So you could put it on like a website where a customer could come and say, I'm having this issue, can you please help me resolve it? And then from there, based on the contents of that chat, we wanted to be able to respond or react. And that's where that arrow number 2 happens, where we don't have any control over that chatbot, so we had to use the new stored procedure for SP, invoke external REST endpoint. you may be looking at this being like, why doesn't the chatbot just do the analysis? There are cases where you don't have control over every service in your environment. And so this is an illustration of one of those cases. Once that happens and it gets called out, then we need to write the analysis of the chat back into the database, the sentiment, what's the quality of the language, that kind of thing. And then last but not least, we can pull the contents of the database out into a CRM dashboard. So a couple APIs being surfaced there. At the end of the day, the chatbot is based on Entity Framework. Awesome. It was great to develop. It has a couple of tables. It has its specific schema. So that is the box at the bottom. The app on Entity Framework Core is that Teams chatbot. So building and publishing that EF chatbot means that we now have some database schema. But we do need to capture the Entity Framework-based schema. And you can do that. You can find out the state of your database. You can script out the schema. The static web app, the React static web app, that was another piece that someone else built. It was definitely not just me building this. In fact, it was mostly not me building this. So someone else then needs to start working on the static web app while the chatbot's getting finished up. And then those Azure functions need to get built, and they're going to have their own components to the database schema. So now we're adding more. So there's some kind of level of creating more schema objects. So we're incorporating multiple application pieces, but we're also incorporating different pieces to the database. The SQL components for the web app and the Azure functions also need to be deployed. And so this is where I'm going to show you how we went about that. But before I do that, I need to introduce a concept. I'm going to talk about SQL projects and demo them here in a minute. How many folks have used or have been scared by or touched or seen in their environment SQL database projects? Cool. To be honest, that is more than I expected. I am delighted. Unless you are all scarred for life, in which case we can alleviate that today. So a SQL database project is a local and a kind of offline rendition of the objects in a database schema. So the primary components of a database project are going to be the scripts, the declaration of tables and stored procedures. But what makes SQL projects more than just a folder of scripts is that there is tooling around them that can validate that database model. Whether it's 3 million objects, seen it, or 100 database objects, that model gets built and compiled together to make sure you're not referencing a foreign key that does not exist. So that's still happening. It's not just a folder of scripts that someone's writing and then like crossing their fingers when they hit execute. You have a build process that does not touch a single database. Now, the other thing about SQL projects is that earlier in the session I mentioned, hey, we have SQL Server and there's different years of that, and then we have Azure SQL Database and Azure SQL Managed Instance. Lots of SQLs. Sometimes you run into a case where you're like, I want to use this feature, but I'm not sure if it is available in X. SQL database projects, not unlike other project types where you can select that target platform, there is a target platform option for SQL projects. So you can say, I want to target SQL Server 2016, 2019, 2022, Azure SQL Database. So you know I'm getting what I'm getting. Now, SQL project containing objects, that's pretty cool, but that's not all. When a SQL project gets built and compiled into the model, it takes into account all those objects. But SQL projects also interface with the deployment of a database. So when you are ready to take your SQL project artifact after it's built and apply it to a dev database or a production database or whatever, maybe the schema objects aren't the only thing you need to do. Let's say you want to, when you're deploying this to a dev instance, insert some sample data. So you have a script that inserts sample data. Or if you're deploying across different production environments, you need to create specific application users. You have the ability to specify additional handcrafted scripts, pre- and post-deployment scripts, that can do other changes, that can do other things, like inserting that static data. Beyond just that, there are a whole number of features to SQL projects that kind of expand out to a lot of potential options. The one that I need to mention, because I'm going to show it to you today, is the ability to pass variables in to be evaluated at publish. So when you build it, the variable stays there undefined. You can have a default value, but then when you publish it, so let's say you want to have a specific value for something when it's going to a test environment, and you want a specific value for a production environment, you can pass those variables in at deployment, which is like, opens up 7 different other avenues to take in your environment. So that's super fun. Okay. Some of you have nodded, which means you are ready to try it, so I'm going to show you how you can try it. They are available in 2 different tool sets. So basically, no matter what stack your environment is in, you can use SQL projects. The basis behind SQL projects, the name kind of suggests it's a .NET thing. Yes, it is. It uses .NET in the background. However, they're cross-platform, and if your application code is Node.js, any of the other things under the sun, you can still incorporate SQL projects in your application development. Not gonna break anything. So if you're using Visual Studio already and you have no desire to leave Visual Studio, stay. Add the data platform workload, and off you go. You have SQL projects. You're good to go. SQL Database Projects is also available as an extension for VS Code and Azure Data Studio, and it also works if you head off into Codespaces or are already in Codespaces. And that, again, is cross-platform. So VS Code is cross-platform. Azure Data Studio is a fork of VS Code and is cross-platform. So basically, you have no excuse to not at least try it. These tools handle your inner developer loop. This is, I am building my application, I'm writing app code in Visual Studio or VS Code. This is where you're developing and building, so like you would do for .NET or Node.js, you develop and build. For SQL projects, you're still developing in T-SQL. You're writing your create statements. Now, the thing about SQL projects that sometimes trips folks up that have gotten used to making iterative changes to their database is you do not need to worry about writing alter statements. You are declaratively saying, I want my database to look like this, and then when the third part of the wheel comes up, those changes are calculated for you. You just need to build that DACPack artifact. That is your SQL project build artifact, is a DACPack. Data Tier Application Package. DACPack. Super fun to say. But what about when you're ready to take this off into dev environment, production environment? That is where there are options from the interfaces like Visual Studio and VS Code to publish from there. You can deploy it out to a database. But in true kind of DevOps style, for that outer loop, there's a fully featured CLI that's available cross-platform, Windows environments, Linux environments, that will do that deployment, that will take your DACPack your SQL project artifact and apply those changes to the database. So you've written your create table statements, you've written your create procedure statements, and SQL package as a CLI can do a whole number of things, but we pull one tool out of that toolbox and we say, I need to be able to publish this DAC to a server. I don't know what the state of the database is right now. I don't need to have it memorized. I don't have to ask a ton of questions. I just need to run this operation. And so it will update the schema of that target database to match the DAC pack. So a SQL package is a CLI. You pick it up for free. It's pre-installed on the GitHub and Azure DevOps runners if you're using the ones that are provided. We keep it pretty much up to date. There's about a 3-week lag on when we release an update to when it gets built into that latest image. But it is available, and it is a command line interface on top of the DACFX framework. So later, when we take that brief detour into DACFX, and I'm like, you can do all these other extra things, SQL package has just simplified some of those into a nice little CLI, but that's where it is. In case we are just a tiny bit fuzzy on what is SQL package doing. You've made your SQL project, you've created a customer table, you're probably more creative in your application development than I am, but let's say for this case you have 2 columns, first name and last name. This gets published out to a database. SQL package can create new databases. So we'll just say initially nothing exists. Now we've created a table with 2 columns. Now, you didn't just like sign off for the day and never come back to the project. You need to do something new. You need to add a region column. So you go back to your SQL project, you open up the customer table file, you hit enter, and then you type region and add the column. You build it, it compiles. You do not need to go, what have I put out on the database? Let me open up Object Explorer, see how many columns. Okay, let me try to remember how to change this. You do not need to do that. What you do is you ask SQL package to publish a DAC pack from your SQL project. And SQL package will say, that table already exists, but the difference is there is a new column, and I will add the column. And I will remember the alter statement. So the declarative part is you declaring I want the table to look like this, and then using the tooling down the road. Yes, demo. Okay. I know that many of you have seen the Visual Studio interface until you are blue in the face, so I'm going to stick in Azure Data Studio and VS Code today. Like I mentioned before, SQL projects are available in Visual Studio right now. The thing that I need to say for those of you who are in the audience that are like, I have been using SQL projects for 5 years plus years, I don't like them for this reason. Many times those reasons, full transparency here, is the performance of the deployments. There are instances where that is slow, and that is something that we have spent a lot of time working on. So if you grab some of the later iterations of SQL package most recently, try those out, and then let me know if you have specific transformations that are still not performing well, because we are continuing to work on that performance. Second reason why people may not like SQL projects is merge conflicts can be messy because of the SQL project file format. And so that is why it is super exciting that we have started working on an SDK-style SQL project. What I have up is a SQL project file, so the .SQL proj, similar to a .CS proj, in the old file format. Now, what gets messy is that SQL proj likes to have a definition for every single file in the SQL project. This is totally doable if you are doing more linear development. It works great for a lot of instances, but if you're in one of those more dynamic environments where people are trying to incorporate changes constantly, it's not pretty. So we have started to move to SDK-style SQL projects. SDK-style SQL projects are not yet available in Visual Studio, but they are in VS Code and Azure Data Studio. We are working on that. Because if I open up an SDK-style SQL project, you will see it is a lot shorter. So it does that default globbing, says, I see all these files in this folder. These are all of my script items. So if you're familiar with SQL projects and you've kind of been sitting here like, oh, I know this stuff. If you didn't know about SDK-style SQL projects, you have something to be super excited about. I know it's early in the morning, but I get super excited about SDK-style SQL projects because they really do open up SQL projects to new development cycles. And they make cross-platform development with SQL projects a lot easier. So in VS Code, I've installed the SQL Server extension and the Database Projects extension. This Database Projects extension has rendered a view of the SQL project in my folder here. We did a mono repo when we built the demo for build for a number of reasons. You may have some applications in your environment that are mono repo, but this is not to say that you have to do that. By all means, it can get super messy. Your database can have its own repository. But I have in this folder checked into source control, my SQL project and all these files. The Database Projects extension has brought this over here, and it gives me new options to do in the interface. A lot of this stuff you can do manually from the command line. You can do that .NET build to build your SQL project. So if you're like an aficionado with that, that's fine. But it is surfaced right here in the UI. So I can say, hey, I want to build the SQL project and make sure that I haven't made any mistakes in the files. It should give me a bunch of warnings because I have stuff that's in private preview. Yep, 19 warnings, awesome. But this is validated that I don't have any bad references in these scripts. So I've got a couple tables. You can see the things that like the chatbot was writing in. You can see the tables that we were creating for the dashboard. I'm going to pop over into Azure Data Studio real quick. You might be looking at this for the first time and being like, wow, that looks really familiar. I think I mentioned earlier, but Azure Data Studio is based on a fork of VS Code. We merge VS Code into Azure Data Studio on a fairly regular cadence, but it has additional UI capabilities and does not contain a lot of the application development capabilities. It focuses on database development, database interactions. So in this case, I've got kind of as that primary object, the connection pane here. You might be wondering, like, how did we get the entity framework schema that was created into our SQL project? And then this is also another potential question that you have is just, we've already created our database. Like, how hard is it going to be for me to take that 1,000 tables and stored procedures and stuff into a SQL project? Like, am I going to be copy pasting for days? The good news is that you can import a database directly into a SQL project. Maybe. There we go. If you right-click on a database in Azure Data Studio, with that SQL Projects extension installed, you have that create project from database functionality right there. So you can create a brand new project really quickly and you're off and running. In Azure Data Studio as well, there's schema compare capabilities as well as updating the project from the database. So what I'm gonna do is I have opened up that same folder in Azure Data Studio as well. So it's showing me the SQL project here. What I'm going to do is I'm going to say, hey, I want to bring that database into the SQL project. This is one of those cases where you have a couple different people working on a project, and you might not be able to get all of them to buy in on using SQL projects. Some folks are still like die hard, I will put changes in a development database and someone else should deal with it. I've met a few of those people. It's all right. That's why update project from database is great. You can import the database into a SQL project for the first time, but you can also update the project from the database later on. So the source is going to be that the database that we just connected to a moment ago, and I could say I want to bring it into this project. One thing about SQL projects is that you can organize the objects however you want, but we provide a few suggestions in case you're like, I'm just going to throw everything in a pile. I mean, you can do that if you want, but I do suggest you consider incorporating like object and schema functionality into your organization. We've done object type organization in our thing, and I'm going to view these changes in schema compare. So this is going to pull up a schema compare panel to let me see if there are any differences in the database versus my SQL project. There may be a few scripting changes that it's going to show us in a second, but overall everything should be the same, so I don't have any changes to apply. This is one of those performance things that I want to work on. There we go. Yeah, it's picking up a scripting change between the way that the primary key was defined. And I think that's going to be just about, yep, perfect. This is a great reminder. So I want to talk about those variables real quick. So let's go into transcript entity. So this table, very similar to the demo yesterday, has a trigger on it to send a message out to analyze the chat that comes in. This is what one of those variables would look like. This is one of those SQL CMD variables for a SQL project. And this is just one example of where one of these variables might be useful. Because you're adding a value to this trigger or a stored procedure that's a URL. I mean, if you're testing in dev, do you want to be throwing things against the same URL that prod uses? Maybe not. And so this value means that when we publish the DAC pack, we can say, this is the test endpoint I want you to send things to, or this is the production endpoint. So you're allowed to establish that in the code. In the SQL project file, this is what a SQL CMD variable looks like. It's just a little bit of a XML definition. You can give it a default value, you give it a name, you're off and running. So that kind of allows you to supercharge the deployments themselves. So we've got build, we've got publish. You can add different items. I mentioned changing the target platform earlier. If you work with folks that are working with analytics and they're like, oh, this schema is getting really messy. I wish I had an easier way to manage a schema. We do work with Synapse dedicated SQL pools as well. All right. So I'm going to pop back over into VS Code, but this is also available in Azure Data Studio because I want to kind of finish talking about that inner loop. When you are developing, some of you may love stubbing out tests and managing to run APIs and test them without a database behind them, but it's not ideal. What is ideal if you have your database schema that you can quickly stand up a dev instance to use. You can have SQL Server, the developer edition installed on your workstation, and then you can just publish right to that. So I can say, hey, I want to publish to an existing server. But maybe you already have enough going on your laptop or your desktop. Maybe you do. If you have Docker installed and running, if you use containers at all or could. I would like to make it as easy as possible for you to take your SQL project and get a development server running quickly. This works for Azure SQL Database as well as SQL Server SQL projects. It will grab the appropriate container image. I'm going to say new Azure SQL Database emulator. It's going to ask me what port I want to use. I need to set a password, so I'm going to do a really secure one. It's going to ask me which base image I want to use. For those of you who develop on a recent macOS device or a Surface Pro X, you can grab the light image. I'm going to grab it now because it is smaller and I might have to download it. But it's going to pull that container image. Don't use a published profile. It's asking me to specify the database name. These are those variables. It's asking, do you want to use the default value or do something different? I'll leave the default values. And it's going to start pulling that container. So when this process is done, I will have my SQL project schema published to a development instance on my machine, and I can get back to developing C#, TypeScript, JavaScript, whatever I do. I love databases. I am not terrible at writing SQL code, although not great either. But I don't like spending most of my time creating databases. I want to do cool things. I want to make APIs. I want to build a web page. I want to work on a mobile app. The database is there and it does great things. Like I like using SQL Server because it's fast and I can build cool things on top of it. But I don't want to spend all of my time building a database and fighting with it. I want to be able to build the schema in a SQL project and just say, yeah, that was fun. Let me check my connection pane. And so now in my connections, it connected to localhost automatically for me, and I have that schema here on my local machine. And if I pop into my Docker extension, it should show us there we go. It should show us that it started up that container for us. And this is like just a development instance, and I know how easy it was to create it, so I don't have to keep it forever. I can get rid of it, come back to it later if I need to. All right. I mentioned very briefly, same thing exists in Azure Data Studio, publish, creating new dev instances, etc. All right, we are down to our last 30 minutes, so I'm going to stop doing live demos for a little bit. So with SQL projects, you're able to take that schema that you've either pulled down from a remote repository, just like those scripts, build it up into a database model. When you're ready to develop and test against it, you can create that development instance pretty quickly. And I do suggest that you highly consider using the SDK-style SQL projects. We are absolutely moving towards those, so it is a great time to start collaborating with a team on SQL projects. Even if you walk out of here today and you're like, it's definitely not going to work in my environment, at least on this project, I'm going to have to hold off. Find another way to get your database components into source control. Use one of the migration-based approaches. We're going to see something in the outer loop that talks about bringing databases into source control directly and just not really developing those objects, but just pulling them in. So please, please keep your database objects in source control. SQL package, the CLI, was our outer loop tool that I mentioned earlier. SQL package gives you the ability to publish that DAC pack to a database like we saw when we set up that development instance in a container just a few minutes ago. But SQL package does a couple other things. DAC packs themselves can be extracted from a database, so you can grab that schema artifact from a database with a command with SQL package. If you're using Azure SQL Database already, you may be familiar with the Backpack file format. That's going to be by default the schema and the data out of the database. It's not a small file sometimes, but it's fantastic for portability. And I couldn't tell you how many command line flags SQL package has. It has a lot of options. For being a simplification of DAC effects, it has a lot of options. So you can say, I only want this table's data, or I don't want you to script out indexes, or so many things. So if you have the time and you would like to be overwhelmed by command line options, check out the SQL package documentation. There is a ton of different ways that you can customize what it does to suit the environment or the process that you have. So if you need to grab, I'm going to use the word snapshot, but I don't mean it in the database way, but just in like the conceptual format, the backpack schema and data of your database, you can do that. You can do that against SQL Server as well, but for Azure SQL Database, it's exposed to the import-export service on the portal as well. Oh, speaking of SQL package command line flags, I love it when I get surprised by my own slides. The general syntax for how SQL package works is you tell it what action you want, and then you start passing in additional parameters. The thing that really takes people by surprise sometimes is that the parameters have short form names. If you use the long form names, you can end up with a very, very, very long command, and that's not fun. So you can use those lowercase short form names. But for example, if you were to say SQL package, I want to extract, so that's taking the database into a DAC pack, so you can apply that schema somewhere else. You give it the source server name, you tell it what database it's looking for, and you tell it what target file where it should save that. You can run that from SQL package on your local machine. You can run that in a pipeline. You can run that from a terminal somewhere. But that's what SQL package does for you. I have a couple pipeline ideas that I want to throw past you. With the original SQL projects, you would be able to, so this is from Visual Studio, and this is also in VS Code and Azure Data Studio, you would be able to create your SQL project code, along with your other code, you check that into source control. Your pipeline would be able to build the SQL project into a DAC pack. It would be able to publish that DAC pack to a SQL Server database, and then you can store those artifacts after the fact. So you may already be storing other artifacts from other pipelines, and you can do that same thing with SQL package, with SQL projects. So with the examples that I'm going to show here, I'm showing it in GitHub Actions. SQL package is also available in Azure DevOps, so these things are compatible to both. With the newer style SDK SQL projects, the build and deploy does run on Linux-based environments as well. And in that case, on the GitHub Actions, the SQL action for GitHub can handle the build and deploy all in one step. So instead of needing to do the MS build and then the SQL package deploy, there is a consolidated step that you give it the SQL project name, and then it runs the build for you. Gives you all those build warnings because we're working on things in preview. And then it runs the SQL package publish for you. Eagle-eyed people may see that v/ function endpoint. That is that SQL CMD variable that is getting set at deployment time. So the pipeline is saying, this is what that URL value should be. This is what the username should be. This is what the static data should look like. However you want to use your SQL CMD variables. But that is the gist of building and publishing a schema update to SQL Server. It seems overly simple, and I'm sorry. You're able to do things like uploading the artifact. So in this case, I said, hey, please take that DAC pack and store it somewhere so I have it for later. Maybe you want to be able to go back and keep a log of that schema. I will be getting the DAC to the organizer so they can post it, and it includes YAML definitions because I know some of you just like itch for YAML. So it'll be there for you to scratch that itch. Okay, so I promised we would look at what does it look like when you want to check what the database looks like and then say, hey, I need to get this into source control. So you may not be using SQL projects. I'm okay with that, as long as you're keeping your database objects in source control. In this pipeline run, we can see that the pipeline ran, and it's telling me that I have a pull request. And the pull request is an update to the database state. The file changes as there's a new index. Cool. So I can tell my DBA that they can work on the database and they can apply indexes, they can help us out with performance tuning, and I can incorporate their changes back into the SQL project for development, or I can just keep track of the changes that have happened so I can use them in other ways in the development process. We can absolutely do that. So what does the pipeline look like that did this magic where it opened up a pull request on the behalf of someone else on my team? It's a couple of steps. For those of you that like command line stuff, buckle up. So there's a folder. There is a folder in this project for the deployed database, where the database is deconstructed to. So the first step is to just remove what's there, and then run SQL package. And it's going to do an extract using SQL package, but instead of extracting to a DAC pack, it's going to extract directly to the scripts. So this is fairly new to the CLI of SQL package. In fact, when I did this demo earlier, I had to install the very latest into the pipeline. It'll be there now for you. But you can run an extract with SQL package in a pipeline on your local machine and bring things right down into their scripts. So this SQL package command that does the p extract target equals object type is populating that folder with these scripts here. All these tables, those constraints, all of that's getting populated by this SQL package extract command. And so it has saved it into that folder. So in this pipeline, we've updated the contents of a folder. If you were doing that locally, you would see source control go to work and say, hey, you have a change in this folder. Do you want to check it in? This is automated. This is in a pipeline. We don't have that opportunity, but we can ask Git to do it for us. So we have to do a little bit of Git magic to have it check for changes and then check those in on behalf of a bot in the pipeline. And we're checking it into a feature branch. So we're not checking right into main, we're checking into a feature branch. So you can grab those database changes, say, hey, I have new files. It looks like once files changed with 6 insertions. Great. opening up a feature branch and making changes doesn't necessarily start any collaboration. It doesn't necessarily set us up to integrate the changes quite enough. Wasn't far enough, at least not for me. So we're going to open up a pull request, which is the pull request we saw a moment ago. And because I like pretty things, GitHub introduced a variable for GitHub step summary. And it parses Markdown into a nice display. So when we go back, that is my GitHub step summary that lets us know if there was a pull request and a link to the pull request. But my DBA had optimized the database by adding an index, and I found out about it because there was a pull request in my repository from a pipeline that was running once a night, saying, here are the changes. Or, never mind, no changes, not gonna bother you. So you can at least incorporate your database into source control that way, but then you can start combining some of these pieces together. It starts to get exciting. All right, so that was about helping other people, but I also want to help you. I mean, that could have helped you too, but I definitely want to help you because one of the things that grinds my gears, I've already mentioned it, is how when you're developing an application, a lot of times you end up stubbing out tests. You're like, yeah, this is going to call the database, and of course the database works. I mean, it works, like we've been getting by, but let's reduce that if we can. And so in your development pipelines, just like we, for our local development environment, stood up a development container, threw our database schema on there, was ready to go, you can do a very similar thing with a sidecar container in a pipeline. So you can say, hey, in this pipeline, you're doing a very similar build and deploy as you would for any other database deployment. But in this case, you're adding a service container for the database that you're using. Let me actually switch to... So yes, so here is your the services section is what sets up the sidecar container. So it gives it the MS SQL DNS name, and then you can give it just kind of developer level information like an SA password. And then in the next step, you have to pause a moment to wait for SQL Server to start up. That's that silly looking bash script. And then you can deploy your SQL project. At the very bottom of the slide, the proof of concept that you can run a query against said schema in the pipeline. And what that ends up looking like is those results output right there. Instead of running a query from the command line, you could run your application tests. Or write database unit tests and go from there. So before I start talking about really fun ideas, just a recap of what we talked about with pipelines. With the SQL action in GitHub, you can consolidate the build and deploy down into one step, but you can certainly break things out with .NET Build and then the SQL package publish directly in your pipelines. You can bring your schema back into your environment bidirectionally. And then last but not least, feel free to leverage sidecar containers to do even more in those pipelines to really elevate what's happening with the validation integration tests for your application. Brief detour. So we talked about SQL package as a CLI, and that really gives us the capabilities for taking our SQL project artifact and doing all kinds of things with it. Publishing it out to a database is a core use case, but fundamentally, SQL package is a layer on top of the data tier application framework. Or think of it this way, as something that looks into your database schema and pulls it apart and treats it like application components. So instead of classes, it's looking at database objects. DACFX is available for .NET Core and .NET Framework. We are working on .NET 6 right now, and it is available as a library on NuGet. There are APIs available. So if you look at SQL package and you're like, this does a lot, but I need something even more powerful, you can grab the DACFX library and make something custom for your environment. All right, so you didn't think that was a terrible idea just a moment ago when I suggested you start doing more .NET development. So let me give you just a brief overview of the two directions that you can take this in, because they're related, but they are slightly different. The first one is that you can start from scratch, build your own .NET console application, bring the DACFX library in, and use the DAC services APIs to do a publish on a DAC pack, do all kinds of fun things, create a database right within that .NET console tool, those kinds of fun things. So if you want to start from scratch, cool. Power to you, that people do it, I promise. However, there's a middle ground. You can still use SQL package. You can say SQL package is doing pretty well, totally willing to use it, but I need to make a modification. SQL package has a lot of command line options, but it doesn't do this. It doesn't skip a table with this name. We have an audit table, and I never want to I want to leave it alone every time. I want to ignore it. Or I want to leave all the triggers alone. Or I don't want to touch indexes that have this in the name. You can reach into the deployment plan that SQL package provides for you with DACFX contributors to SQL package. What that entails is instead of starting from scratch with a .NET console application, you're going to build a class in a .NET project, in a CS project. You're going to build a class for a SQL package contributor, and it's going to define how it should modify those deployment steps. When you run SQL package, you say, hey, I want you to grab my additional deployment contributor that I have named public.dac.sample.sampleFilters.planFilter. Very good naming classes, as you can tell. So the sample that I will make sure gets linked into the deck that you get, in case you really want to dive into this idea, is a sample deployment contributor that shows how the DACFX framework is able to look at the steps that SQL package provides for the deployment. So every time SQL package runs, creates that deployment plan. The deployment contributor itself can look at every step and ask questions about the steps. What are the object names? What are the object types? Is it using a specific feature? Is it doing an index online operation or index offline operation? You can ask all kinds of questions. The example that we provide is fundamental to the level of filtering based on the object name. It just checks for the table name customer. But what it can do is remove, add, or move deployment steps. And in this case, we don't want to touch the customer table, so we can remove deployment steps that touch the customer table. So up until this point, you might have been hearing about SQL projects for local development and then SQL package for deployments in your environment and been like, we have some really interesting things that we do in our environment, and I am never going to be able to get them to change those things. That's okay, because you can really fine-tune that control with a DACFX deployment contributor. So you still get to use SQL package, but then you get to touch on it even further. All right. Wow, we went through a lot today. I mean, when we looked at this slide earlier, I was like, this is kind of an abstraction on top of the DevOps principles. But with that inner loop, we were able to, along with our application code, have a SQL project, maybe in its own repository, maybe right there with the application code if you really like mono repos. But anytime we needed to do development work for that, we were able to stand up that dev container locally real quickly based on the database schema. So if you're using SQL Server, it's going to grab the SQL Server container. If you're using Azure SQL Database, instead of needing to call someone that has permission or stand up an instance and like make yourself a sticky note so you don't forget to delete it, or do neither of those things and just rack up a bill, just use the Azure SQL Database local emulator. It'll be there on your machine. No one gets upset with you for a build. So you can keep that inner loop do your development along with the great people you work with. And then as you check that code into source control, it becomes a part of the continuous integration of the rest of your application. I alluded to a few minutes ago about, maybe your SQL needs unit tests. That is not an impossible thing. Within Visual Studio, there are unit tests for SQL that are C# based, but there's also a great community project for SQL-based unit tests, and those can be integrated into your pipeline. So once you've started into the road of keeping your SQL in source control, it can truly become a part of the same processes that the rest of your application code has. You've got your database code coming into that outer loop going into source control, but it also needs to get all the way to your production environments. And so that is why it is great that you've already been able to incorporate quality checks. Now you're more comfortable with the deployments that go out the door. And we start getting back to the fundamental principles of DevOps that we talked about where, frankly, we just want to ship things more often. If we're going to build cool things, if we're going to make a difference for the companies that we work at, we want to see that get out the door. And so that's why moving all the way from the inner loop to the outer loop and doing it effectively is so important. Leaving SQL out of the picture is not exactly the solution. So if you can use any of these tools that we've talked about today to bring that closer together, then you've gotten something out of that, and I am satisfied. Okay, so before I forget, because I forgot at the beginning, I got too excited to talk about this. My teammates and I are all going to be over at the Mixer when you guys go over there for lunch today. So if you see me or other people that I'm standing around with, they are my fine colleagues who also work in the world of SQL tools and experiences. So please come talk to us. We would love to hear from you about what's working, what's not working, what you just wonder if it could work. We would love that. So I look forward to seeing you over there. Thank you for your time. Please fill out the survey.